Okay, let's dive into this. Welcome to the Explainer. Today we're doing something really cool. We're not just staring at some dry, dusty compliance document or a theoretical checklist. No, we're going to completely decode the NEBOSH risk assessment framework by getting our hands dirty in a real-world, high-stakes industrial environment. We're literally stepping into the boots of a safety assessor at a place called ABC Cement Limited, and we are going to build a risk assessment right from the ground up. To do that, we've got a straightforward roadmap today. 1. Setting the stage. 2. Identifying workplace hazards. 3. Evaluating real risks. 4. Upgrading controls. 5. Creating an action plan. And 6. Legal and global standards. Section 1. Setting the stage. Organization, scope, and evidence. So here's our scenario. ABC Cement Limited is a cement manufacturing company employing approximately 420 workers operating in 3 shifts. The organization consists of the quarry, crusher, raw mill, kiln, cement mill, packing plant, and maintenance workshop. Think about that for a second. 420 workers, massive heavy machinery running around the clock. These aren't just numbers on a page, right? This is a sprawling operation where the stakes are incredibly high and the risks are staring you in the face every single day. Now, how do you even begin to tackle a beast of an organization like this? Well, you've got to draw some boundaries. Section 2 establishes our scope. We are focusing squarely on routine maintenance around the rotary kiln. This includes the mechanical technicians, the operators, and the contractors. Notice what's missing? We're purposefully excluding those safe, quiet office areas. We want our attention right in the danger zone during normal production because that is where the heavy lifting and, honestly, the heaviest risks are happening. And this brilliantly illustrates why Section 3 is so absolutely vital, how information was collected. Look, a life-saving assessment cannot just be built on assumptions or guesswork. We need hard evidence. We're talking workplace inspections, direct observation of activities, employee and supervisor interviews, accident and near-miss reports, permit to work in maintenance logs, and safety data sheets. We are building our assessment on verifiable, undeniable facts straight from the factory floor.
Section 2. Identifying key workplace hazards, the dangers at ABC Cement.
When we look at Section 4, hazard identification, we quickly spot the big 3 hazards out there. First up, working at height. We're talking falls from those elevated rotary kiln platforms, which can cause severe fractures or, worse, fatalities. Second is rotating machinery. Operator entanglement here can literally result in amputations or horrific crushing injuries. And third, cement dust. Continuous exposure leads to respiratory diseases and severe skin and eye irritation. See what we did there? You always have to link the specific source of danger directly to the severe human consequence. Section 3. Evaluating the real risks, existing controls, and risk ratings. We gotta start by looking at Section 5, existing control measures. What do they actually have right now? Well, for height, they've got a permit-to-work system, full-body harnesses, and fixed ladders. For machinery, machine guards, emergency stops, and lockout/tagout procedures are in place. And for the dust, local exhaust ventilation, dust suppression, and basic PPE. Keep in mind, this section strictly looks at what precautions exist right in front of you today, not what you wish existed or what's on back order for next year. Let's move to the next step and see how this builds right into the risk evaluation process in Section 6. It's a super logical 4-step sequence. Step 1, look at those existing controls. Step 2, assess the likelihood of an incident. Step 3, assess the severity of the consequences. And Step 4, assign an overall risk rating. We are basically using the existing controls to carefully weigh the likelihood of an accident against just how bad that accident would be. Let's take the working at height hazard as a real-world example. Here, the likelihood of a fall is considered medium, mostly because basic fall protection and ladders are actually already provided. But, and this is a big one, the severity is high, because if those controls fail, a fall from the kiln results in fatal injuries. This perfectly contrasts a medium likelihood against an extreme severity, which really shows you the true nuance of calculating risks out in the real world. So the crucial point here is how we define a high-risk rating. It's an unacceptable level of risk where, despite existing measures, the potential for fatal consequences demands further immediate action. Because the severity remains fatal, meaning someone could literally lose their life, the overall risk rating stays high. This rating isn't just a label, it's a massive red flag. It acts as an immediate trigger demanding that we find better solutions, like right now. Section 4. Upgrading safety controls, moving down the hierarchy of controls. Now, what's really interesting here is the evolution of safety measures we see in Section 7. Check out the transition. We are moving from existing controls, like full-body harnesses and basic exhaust ventilation, which honestly rely heavily on worker behavior, over to additional, much stronger controls. We're talking permanent guardrails, mobile elevated work platforms, interlocked machine guards, and upgraded ventilation. We're actively upgrading from reactive PPE to proactive engineering controls that just physically remove the danger altogether. Section 5. Creating an action plan, turning recommendations into reality.
So, ideas are great, but Section 8, the action plan, is where we turn them into reality. It uses a really simple but incredibly effective structure. Action required, responsible person, and time frame. For instance, Action 1, install permanent guardrails. Who's on it? The maintenance manager. When? Within 30 days. Action 2, upgrade local exhaust ventilation. That falls on the engineering manager, and they've got 45 days. Action 3, conduct annual lung function tests. HSE manager, 60 days. This shows you exactly how a proper risk assessment organizes tasks for absolute accountability and super fast execution.
But hey, the job isn't done just because you handed out some tasks. Section 9 outlines exactly when to review the assessment. A risk assessment is a living, breathing document. You absolutely have to review it post-accident or near miss, or if you bring in new equipment or make significant process changes. You also review it when new legislation drops, or at the bare minimum at a scheduled interval, usually annually. These specific triggers force a facility to constantly reevaluate its safety game. Section 6. Legal and global standards, the framework behind the framework. Let's quickly summarize the fundamental legal obligations of employers. They are required to provide safe equipment and maintain machinery, ensure safe systems of work, provide information, training, and supervision, consult workers on health and safety, and supply appropriate personal protective equipment. The rigorous assessment we just built together, it's not just a nice-to-have suggestion. It is quite literally a legal requirement to protect people's lives. And if we zoom out to a global scale, we look at standards like ILO Convention No. 155 and Recommendation No. 164. This dictates the employer's responsibility for safe access, effective supervision, machinery guarding, and training for heightened machinery hazards. Notice how perfectly these international standards map directly onto the specific physical hazards, like the rotary kiln and those height risks that we found at ABC Cemert. And for our cement dust hazard, well, ILO Convention No. 170 and Recommendation No. 177 require hazard identification, local exhaust ventilation, health surveillance, and proper safety data sheets for chemical and dust exposure. That connects straight back to the dust hazard we just analyzed. It shows exactly why we mandated upgraded ventilation and those 60-day lung function tests in our action plan. The overarching standards actively inform the on-the-ground actions. All right, as we wrap up this explainer, I want to leave you with one critical, maybe even a bit provocative question. Are your existing controls actually enough to protect your workers? Don't just assume they are. I really urge you to look at your own workplace, your own processes, with the critical, objective eye of a true risk assessor. Thanks so much for joining me today, and keep striving to build a safer environment out there.